Here are some shaded shapes on a square grid. Write the letters of the two shapes which are hexagons. So remember, a hexagon is a six-sided shape. So what we need to do for this part of the question is just count the sides. So A has 4 sides, B has 6, so that's one of our hexagons, C has 5, so that's a pentagon, D has 6 sides altogether, so that's our other hexagon, and then E has 5 sides, so that's a pentagon. Now write the letters of the two shapes which have right angles. So remember, a right angle is a 90-degree angle, and that's the same size as the corner of a piece of paper or the corner of this screen. Now A doesn't have any angles that look like they might be right angles. We've got 2 obtuse angles and 2 acute angles. Now if we look at B, this angle here perhaps you think might be a right angle, but it's not, and the way that we know it's not is by counting lines down and across. So if we go down and across this way, we go 1 down and 1 across to get to the line, so that's looking good. But if we go down and across the other way, we go down 1 but across 2 to get to the line. So this angle here is not a right angle. Now if we look at shape C, this angle here at the top looks like it might be a right angle, and we can go down 2 and across 2 to get to the line, and in the other direction again down 2 and across 2. So we're going down and across by the same number of squares to get to the line, or we could go down 1 across 1, down 1 across 1. So this angle here is a right angle. So C is one of our shapes, but there's another shape which has a right angle as well. And this one, we can see clearly this angle here is a right angle, so shape E is our other shape which has a right angle. Here is a design on a square grid. Complete the design so that it is symmetrical about the mirror line. So if it's symmetrical, that means it's reflected so that we have the same on both sides. And the way to do this is to dot our corners of the shapes that we have. So these 2 corners are on the mirror line, so they'll also be on the mirror line when we reflect the shape. Now this point here is 2 squares to the left of the mirror line, so we can go 2 squares to the right of the mirror line and dot our point. And this point here is 3 squares from the mirror line, so we can go 3 squares from the mirror line in the other direction. This point here is 3 squares to the right, so we can go 3 squares to the left and dot our point. This point is 1 to the right, so we go 1 to the left, and this point is 4 squares to the right, so we need to count 4 squares from the left. So now that we've dotted our points, dotted our corners, all we need to do is join them up, and we've reflected our shape so that it's symmetrical. Millie has some star-shaped tiles. Each edge of a tile is 5 centimetres long. She puts 2 tiles together to make this shape. Work out the perimeter of Millie's shape. So remember, the perimeter of a shape is the distance around the outside of the shape. We know that each side is 5 centimetres, so what we need to do is to count or work out how many sides we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 sides around the outside of our shape. Now if each of these sides is 5 centimetres, we can find our perimeter by working out 18 times 5, and that gives us 90, so the perimeter is 90 centimetres. Notice, to find our perimeter, we don't count these sides here that are on the inside of the shape, and that's because to find perimeter, we only count edges on the outside of the shape, so we don't need to count these edges here when we're finding our perimeter. Here is a shaded square on a grid. Shade in 3 more squares so that the design is symmetrical in both mirror lines. So if we take this mirror line first, we can see that to make it symmetrical, we need to shade in this square here, so that we have the squares reflected so that they're the same on both sides. And now, if we look at this mirror line, we can see that the squares we need to shade in are this one here and this one here, because that way they're the same distance from the mirror line on both sides. So we need to shade in these 3 squares here to make the design symmetrical. This jug holds half a litre, this bucket holds 5 litres. How many full jugs of water are needed to fill the bucket? So for this question, we need to remember that a litre is 1000 millilitres. So that means half a litre is 500 millilitres, because half of 1000 is 500. And this bucket must be 5000 millilitres, because if 1 litre is 1000, then 5 litres will be 5000. So we need to know how many full jugs of water, so how many 500 millilitres are needed to fill the bucket, so needed to make 5000 millilitres. And 500 times 10 is 5000, because remember, when we multiply by 10, we can just put a 0 on the end if it's a whole number, so 10 jugs of water are needed. And what we're really doing for this question is dividing 5000 by 500. And remember, when we have end zeros in a division question, we can cancel them, and then we have 50 divided by 5, which is 10. So that's why our answer is 10 jugs. This diagram shows 2 identical rectangles on a coordinate axis. Write the coordinates of point A and point B. So here we're told that the rectangles are identical, and that's important because it means that we know that these 2 rectangles are the same size. So we want the coordinates of point A. Remember, the first number will be going down, so looking at the x-axis, and then for our second number in the coordinate, we'll be looking at the y-axis. So if we go down first, we know that the x-coordinate of A will be 12, because we have 12 as the first coordinate here and here as well. So for point A, the x-coordinate is 12, but then we don't know the y-coordinate. We do know that along this line, the y-coordinate is 3, and along this line at the top, the y-coordinate is 9. That's because the second number is 3 here, so we can go across and write it on our y-axis, and then the second coordinate here is 9, so we go across and we can write that on our y-axis as well. But we want the y-coordinate of point A. And remember, because these rectangles are identical, so the same size, there'll be the same distance between them. Because the difference between 3 and 9 is 6, the difference will be 3 here and 3 here. So in the middle of 3 and 9, we have the number 6, which means that the y-coordinate will be 6. But now let's find the y-coordinate and the x-coordinate of B. We don't know what the x-coordinate will be. We know that here, for this line, if we go down, the x-coordinate is 5, because we have a 5 here. And we know that the x-coordinate here is 12, but we don't know the x-coordinate here. So how can we find out? Well, we know that the difference between 5 and 12 is 7, so this length here is 7, so the length of this rectangle is 7, and the rectangles are identical, so the length of this rectangle will be 7 as well. So 12 plus 7 is 19, which means that the x-coordinate of B must be 19. If we have 5 here and 12 here, That gives us a length of 7 because 12 minus 5 is 7. And if the length of this rectangle is 7 and the rectangles are identical, then the length of this rectangle is 7 as well. And now to find the y-coordinate, if we look across, we can see that that's 3, because it's the same as the y-coordinate that's written here. It's on the same level. So the coordinates for B are 19, 3. Write in the missing digits. So here we can see that the tens digit of one of the numbers that we're multiplying is missing, and the ones digit of our answer is missing as well. Now there are different ways that we can solve this question. We could try writing it out as a column multiplication, but notice that we have both of our ones digits in our question, so we can work out the ones digit of our answer. 3 times 7 is 21, and that ends in a 1, so we'll have our answer ending in a 1 as well. 3 times 7 is 21, and because that ends in a 1, our answer must end in a 1. Now, what I would do next is estimate, so to make a sensible guess as to what our tens digits could be. And the way to do that is to round. 300 times 50 is 15,000, because 3 times 5 is 15, and then we have 1, 2, 3 end zeros in this question, so there's 3 end zeros in our answer. Now 300 is just a little bit less than 323. If we try 47, that's close to 50, and then our answer is close to 15,000. So now that we've made some good guesses as to what these digits could be, what we can do now is try it out. So do the column multiplication and see if that gives us the answer that we need. And when we use column multiplication, it does, so we can be confident that our missing digits are 4 and 1. The three numbers missing from these boxes are all prime numbers greater than 3. Write in the missing prime numbers. Now remember, a prime number is a number with only 2 factors. A prime number is only in the 1 times table and its own times table. So we need a prime number greater than 3. 4 is not a prime number because that's in the 2 times table. 5 is a prime number, but if we try dividing 1001 by 5, we'll get a remainder, and we need 2 numbers that multiply and don't give a remainder. 6 is not a prime number, that's in the 2 and 3 times tables, but 7 is a prime number, so let's try dividing 1001 by 7. We can use short division for this, and that gives us 143. So if one of our numbers is 7, the other numbers will have to multiply to make 143. Now you might be thinking, 143 isn't in any of our times tables. But remember, times tables don't stop at 12 times 12. One of our numbers might be greater than 12. Now after 7, the next prime number is 11. So what we can do is try dividing 143 by 11. 14 divided by 11 is 1 remainder 3, and 33 divided by 11 is 3, and 13 is a prime number as well. So we know from this that 13 times 11 must be 143, and then 143 times 7 gives us our answer. So our missing numbers are 13, 11 and 7, and they're all prime numbers because they only have 2 factors. 13 is only in the 1 and 13 times tables, 11 only in the 1 and 11 times tables, and 7 is only in the 1 and 7 times tables. So we have our missing numbers. Write the missing numbers. So we need to find factors of 20. Now remember, Factors of 20 will be numbers that we can divide 20 by without leaving a remainder. So 20 is in what times tables? Well, it's in the 1 times table and the 20 times table, but 20 is also in the 2 times table, and because 2 times 10 is 20, 10 will be a factor as well. So it's useful to think of factors in pairs. Because 2 times 10 is 20, we know that both 2 and 10 must be factors of 20. And we also know that 4 times 5 is 20, so 4 and 5 are our other factors. We can divide 20 by all of these numbers without getting a remainder. Circle the numbers that are equal to 1/2. Notice it says circle the numbers with an S on the end, which tells us that we'll need to circle more than one number. So we're given a fraction, but we have decimals. So let's change our fraction into a decimal. Remember, the first digit after the decimal point tells us how many tenths we have, and we can change 1/2 into tenths by finding an equivalent fraction with a denominator of 10. 2 times 5 is 10, and what we do to the denominator, we do to the numerator as well. So 1/2 is the same as 5 tenths, and as a decimal, we write that as 0.5, because the first digit after the decimal point is the tenths digit, and we have 0.5 here. But remember, it said circle the numbers, so there must be another number that is equal to 1/2. Remember, we can put zeros on the end of decimals without changing them, so 0.5 is the same as 0.50, because all this 0 in our hundredths place tells us is that we don't have any extra hundredths. So we need to circle 0.50 as well, because that number also tells us that we only have 5 tenths and we don't have any ones or any hundredths. 5.0 is not going to work, because remember, the digit before the decimal point is the ones digit. So this number tells us that we have 5 ones, and we can't use this number here, because in this number, the 5 is in our hundredths place, but with 1/2, that's the same as 5 tenths, not 5 hundredths.